we are going to take a look at some more exponents in our radical functions packet. So if you would, please join me on page 11. And we're going to take a look at zero and negative exponents. So right before this, we looked at a refresher of some exponent rules that you have seen before, adding exponents, power to a power, quotient rules, things like that. So now we're going to take a look at zero and negative exponents. So as we work towards the idea of what do zero and negative exponents mean, I want to start with some exponents that we're familiar with. So we've got 2 to the 4th, 3 to the 4th, 10 to the 4th. These are things that we've worked with before. So 2 to the 4th means 2 times 2 times 2 times 2. 2 multiplied by itself 4 times. That would give us 16. 2 cubed would be 2 multiplied by itself 3 times, which is 8. 2 squared is 4. 2 to the first is 2. If I look at my powers of 3 here, 3 to the 4th would be 81. 3 cubed is 27. 3 squared is 9. 3 to the first is 3. 10 to the 4th would be 10,000. 10 cubed would be 1,000. 10 squared is 100. And 10 to the first is 10. I want you to notice here for each of these, as we've reduced the exponent, we have essentially taken out a factor of 2 or 3 or 4. So for each of these, to get from 2 squared to 2 to the first, to get from 2 to the 4th to 2 cubed, we divided by 2. As we go down the list, we're dividing by 2. For our powers of 3, for each of these, as we go down the list, we're dividing by 3. For our powers of 10, as we go down the list, we're dividing by 10. Okay, so we're going to use this pattern to help us now continue to reduce those exponents. So I know that to get from 2 to the 4th to 2 cubed, I can take my result from 2 to the 4th and divide out 2. I'm multiplying by 1 less 2 here. So instead of 4 2's, now I've only got 3 2's. If I know how much 4 2's multiplied together is, I can divide one of them out to get 2 cubed, to get 3 2's. If I know how much 2 cubed is, how many 3 2's is, I can divide out a 2 to get 2 squared. So that's the pattern that we're going to continue here. So I know that 2 to the first is 2. If I reduce the exponent, I can just divide out a factor of 2. Reduce this now, 2 over 2 is 1. If I reduce the exponent again, so now I've got 2 to the negative first, I can take my answer from the previous problem and divide out a 2. I can't really reduce that. That would just be 1/2. But then if I take my 1/2 and I want to reduce the power again, I can use 1/2 to figure out what this would be. I'm going to take my 1/2 and divide it by 2. So this would be 1/2. When I divide a fraction, we're going to multiply by the reciprocal. So that would give us 1/4. If I want to reduce the power again by another one, I can again take this 1/4 that I already have and divide out another 2. So 1/4 divided by 2 would give us 1/4 times 1/2, which would be 1/8. I can do that with my 3's as well. So I know 3 to the first is 3. If I want 3 to the 0, if I want to reduce the power, I can divide out a factor of 3. So 3 to the 0 would be 1. If I reduce the power, I can take my last answer and divide out a factor of 3. And that, again, just gives me 1/3. I can't really reduce that. But then if I reduce the power again, I can take my old answer and divide out another 3. So that would be 1/3 times 1/3, so 1/9. And then again, if I want to reduce the power, I take my previous term and divide out another 3. So that would be 1/9 times 1/3, which would give me 1/27. And we could do this again with our 10s, our powers of 10. So I know that 10 to the first is 10. If I want to reduce the power, I just divide out a 10. So 10 to the 0 power would be 1. To get 10 to the negative first power, we take our previous term and divide out a 10. To get 10 to the negative 2, we take our previous term and divide out a 10. So that would be 1 over 10 times 1 over 10, which is 1 over 100. And then to reduce the power again, I take my previous term and again divide out a 10. So that would be 1 over 100 times 1 over 10, which would be 1 over 1,000. Now I want you to notice some patterns here. 2 to the 0 power is 1, 3 to the 0 power is 1, 10 to the 0 power is 1. Any term to the 0 power is going to be 1 as long as our term isn't 0. Goofy things happen with 0, but any non-zero number to the 0 power is going to be 1. And this should make sense. Anything to the first power is just itself. So if I had 107 to the first power, that would just be 107. If we followed this same pattern here to find 107 to the 0 power, that would be our previous term, divide out a factor of that number, and we would get 1. So anything to the 0 power is 1. And then when we use a negative exponent, again, these are for non-zero numbers. When we use a negative exponent, I want you to take a little bit closer look at what's happening with our negative exponents here. So 2 to the negative first was 1 over 2. 3 to the negative first was 1 over 3. 10 to the negative first was 1 over 10. 2 to the negative second was 1 over 4, or 1 over 2 squared. 3 to the negative second was 1 over 9, or 1 over 3 squared. 10 to the negative second was 1 over 100, or 1 over 10 squared. We see a similar pattern for our negative third powers here. 1 over 8 I could represent as 1 over 2 cubed. 1 over 27 would be 1 over 3 cubed. 1 over 1,000 would be 1 over 10 cubed. And in fact, I could write this 1/2 as 1 over 2 to the first. And this could be 1 over 3 to the first and 1 over 10 to the first. So when I use a negative exponent, what I'm doing is essentially flipping this into a fraction. So if I have a to the negative power, what I'll really get is 1 over a to that power. So if I have, we'll use our 107 again. If I have 107 to the negative fifth power, what I would get is 1 over 107 to the fifth power. And we're probably not very familiar with powers of 107, but we are familiar with powers of 2 and 3 and 10 and 4 and 5. So with this idea in mind, let's take a look at some of our examples down at the bottom of page 11. So if we want to evaluate 5 to the negative third power, this would be 1 over 5 cubed. I know that 5 cubed would be 125. So what I get here is 1 over 125. For our second example here, there should be parentheses around this 1/2. So we can use our quotient power rule. This would be 1 to the negative third over 2 to the negative third. And then since I've got negative exponents here, we're going to move them to the other parts of the fraction. We're going to swap them. So we would get 2 cubed over 1 cubed. When I swap them, their exponents are no longer negative. That's essentially what I did here. I said this is 5 to the negative third over 1. So swap it to the other part of the fraction, and now its exponent is not negative anymore. So I did the same thing here. So this would be 2 cubed is 8, 1 cubed is 1. So I would get 8 here for my final answer. And then finally, I've got 5 to the negative 7 to the 0 power. So we have a couple things in play here. I could, if I wanted to, simplify inside the parentheses first, but I want you to notice we're taking this to the 0 power, and anything to the 0 power is just 1. So I could, if I wanted to, apply that power rule, that power to a power rule that says we would multiply those exponents. That would give me still 5 to the 0, and anything to the 0 power is 1. Let's take a look at a few more examples on the next page. So go ahead and turn the page for me. We're going to take a look at page 12 with our 0 and negative exponents. So let's take a look at example 6 up at the top here. I've got 4a to the negative third b to the 6th over 16 a squared b to the 6th c to the negative 5th. I want to start by moving any terms that are not in the correct places. So that means anything that has a negative exponent, I'm going to move to the other part of the fraction. So my a to the negative third and my c to the negative 5th. So that would give me 4b to the 6th, c to the 5th. When I move it, its exponent is no longer negative, over 16. I have 8 squared on the bottom already, and now I'm going to add a cubed to that, and then b to the 6th. Now I want to reduce. So 4 and 16 I could reduce. We reduce it the same way I would reduce 4 over 16 any other day, which is that I'm going to look for any common factors. 16 I know is 4 times 4, so I can reduce a factor of 4. So that would give me, if I wanted to write just that 1 on top, I could, with a 4 left on bottom. And then I've got 2a terms on the bottom. So since I'm multiplying things with the common base, I add their exponents. So that would be a to the 5th. And then I've got a b on top and on bottom. So we would subtract our exponents. 6 minus 6 is 0. So my b's are gone. So what we're really saying here, we didn't talk about this last time because we didn't know about 0 exponents. But I've got b to the 6th over b to the 6th. So subtract their exponents and we get 0. So that's gone because anything to the 0 power is just 1. So our b's are gone if they reduce to 1. And then we've got just this c term on top. So that would be my reduced problem there, my reduced expression. Let's take a look at a few more examples here at the bottom of page 12. Number 23, on top, this is all to the 0 power. So on top, this just simplifies to 1. On the bottom, I've got a negative exponent, so I want to move that to the other part of the fraction. So I would have w to the first, or just w on top. On the bottom, 4y squared. There, I have no like terms to combine. There's nothing else I need to simplify there. For number 24, on the top, I've got a power outside of a power, so I'll want to distribute that in. But I also have something with a negative exponent here. So I'm going to go ahead and move this up to the top. If you want, you can distribute it to the a and b first and then move the a and b. You're going to do the same work. So this would give me a to the 2 times 2, b to the 3 times 2, and then times a b squared. When I move this to the top, it's no longer a negative exponent. And now this, let me simplify these here. 2 times 2 is 4, 3 times 2 is 6. This part would be a squared b squared. So I have some more like terms I can combine. A to the 4th and a squared, add the exponents, I get a to the 6th. And then b to the 6th times b squared would give me b to the 8th. For 25, y to the 0 is just 1. And then I've got something with a negative exponent here, so I'm going to move that to the other part of the fraction. That would give me x to the 4th times x squared. So I'll add those exponents and I get x to the 6th. For number 26, I want to go ahead and distribute in these exponents first. I know I've got a negative exponent here. I want to distribute that in before I move it. So this would be 6 squared, and then a to the negative 2. Negative 1 times 2 is negative 2, and then b squared. On the bottom, I would have b to the 8th, since 2 times 4 is 8. Now I want to take this term with the negative exponent and move it to the other part of the fraction. 6 squared gives me 36. And then I would have my a squared on the bottom. And then I want to combine my b terms. So I'm going to do big minus little. So 8 minus 2 is 6, and it will stick on the bottom because 8 is bigger than 2. 8 is the bigger exponent. So I have b to the 6th on the bottom. For number 27, I've got a power I need to distribute, and I've got some negative exponents I need to move. So I'm going to go ahead and distribute that power and move my negative exponents. I'm going to do a couple things in one step here. So I would have 3 squared, r squared, and t squared. 3 squared is 9, and then r squared, t squared. I have an r squared, or an r to the negative first, sorry, that would move up to the top. And then on bottom, I've got t squared, u to the 7th, and this u to the 4th, u to the negative 4th, I should say, will move to the bottom and become u to the 4th. From here, I want to combine my like terms. So on top, I've got a couple of r's. So I want to add those exponents. I would have 9r cubed. Then I also have t's. I've got t squared on top and bottom. 2 minus 2 would be 0. So my t's are gone. And then on the bottom, add my exponents on my u's. 7 plus 4 would be 11. So u to the 11th on the bottom. Number 28, I'm going to start by distributing. Actually, we'll go ahead and swap to start. So everything on the top has a negative exponent. It's going to move to the bottom. The bottom is a quantity with a negative exponent, so it will move to the top. So I would have m squared t cubed to the first power, and then on the bottom, m cubed t cubed. Now, since this is to the first power, 2 times 1 is 2, 3 times 1 is 3. I don't really have to worry about that. What I can do from here is reduce. So I can reduce my m's, big exponent minus little exponent. This would be 3 minus 2, that's 1. So I'd have m to the first on the bottom, or just m. And then I've got t cubed on top and bottom. So that would be 3 minus 3, which is 0, nothing left there. Now, since my only remaining term is on the bottom, I do need to make sure I put a 1 on top here as my numerator. And then m to the first, or just m on the bottom there. 29 looks like a tricky problem, but everything in that quantity is to the 0 power. So this is just 1. Doesn't matter how this simplifies in here, since everything's to the 0 power, just 1 there. And then finally, for number 30, I'm going to start by moving my negative exponents. Since the entire top has a negative exponent, I'm going to move all of those terms to the bottom. And then this m to the negative 6 will move up to the top, become m to the 6th. On the bottom, I've got 4 n to the 4th that's going to stay down there. And then I'll have negative 2 m n squared to the 3rd power. Once I move it, it's not negative anymore. I want you to notice that my negative 2 did not change signs. The sign on the exponent changes when I move it to the other part of the fraction, but this is not an exponent. This is just the number negative 2. I do not change the sign of numbers when I move them. Be careful with that. Now I'm going to go ahead and cube all of these pieces. So this would be negative 2 cubed, which gives me 8, and then m cubed, and then n to the 2 times 3, that would be 6. So I'm going to go ahead and look at combining my like terms from here. So, oh, sorry, that should be negative 8 since it was negative 2 cubed. So 4 times negative 8 would be negative 32 on the bottom. And then I've got an m on top and on bottom. Big minus little, 6 minus 3 would be 3. So m cubed on top. And then I've got n to the 4th and n to the 6th. Add those exponents. I would get n to the 10th on the bottom. So that's 0 and negative exponents. 0 as an exponent reduces our term to 1. For those negative exponents, I want to move them to the other part of the fraction, and then simplify and combine our like terms using our exponent rules as we did before.